Good morning, everyone. Today we are going to finish the remaining parts of our third chapter, acids, bases, and salts. Already we have discussed about the acid in details. We are going to read about the bases in salt, and finally we will discuss about the salts as well. Let us see that how we classify the bases. The bases are being classified as the classifications of acids have been done. Like a strong base, that is alkali as well. When we dissolve this alkali NaOH in water, we find that it dissociates completely into ions. That is, out of 100 molecules of NaOH, all the 100 molecule will dissociate into sodium ion and hydroxyl ion. That is complete dissociation. That is why we say it is strong base. Weak base is also as well. When you dissolve ammonium hydroxide, which is a weak base, we find that out of 100 molecules, very few molecules dissociate into hydronium ion, hydroxyl ion, at the same time ammonium ion. So number of hydroxyl ion in ammonium hydroxide is very less, and we classify it as weak base. On the basis of amount of water in the base, we classify again the concentrated base and the dilute base. If percentage of alkali in aqueous solution is a high, percentage high of hydroxyl ion in the water, it will be called concentrated base. If low percentage of alkali in water, then that will be called weak base at the same time. On the basis of the number of hydroxyl ion in the bases, we again classify the base as well as we classified the acid at number of hydrogen ion in them. We see that monoacidic base is one of them. Monoacidic base means in that very base there is only one hydroxyl ion when one molecule is dissolved in water. So let's see that NaOH, when dissolved in water, it will give Na plus and a single hydroxyl ion OH minus. So this NaOH will be called monoacidic base. Similarly, diacidic base Cu plus plus 2OH minus, that is copper hydroxide, when dissolved in water, we find that there are two hydroxyl ion when dissolved in water out of one molecule of copper hydroxide. Therefore, copper hydroxide is called diacidic base. Again, on the basis of hydroxyl ion, FeOH whole 3. FeOH whole 3 when dissolved in water, we find that there are 3 hydroxyl ion liberated, furnished by this FeOH whole 3 when dissolved. Like this way, Fe3 plus 3OH minus. So there are 3 hydroxyl ion when FeOH whole 3 dissolved in water. Therefore, it is called triacidic base. In this way, we classify different ways to the bases as well. Now, preparation. How we prepare bases? When metals are allowed to combine with oxygen, it forms metallic oxide. The metallic oxide like Mg plus O2, that MgO, we find Mg plus O2, MgO. Mg plus O2 is MgO. This MgO is also a kind of base. So this base is one kind of base, one way of preparation of base. Second way how to prepare. When this metallic oxide dissolves in water, like K2O, Na2O, when dissolved in water, it forms 2KOH. This 2KOH is what? What is KOH? A kind of base that it liberates hydroxyl ion when dissolved in water. So this is another way to prepare bases. Now third way how to prepare base. When a salt is dissolved in aqueous solution of one kind of base, AlCl3 plus 3NaOH, we have 3NaCl plus HOH whole 3. So this is another kind of base that we prepare. So this is the kind of base how we prepare. The fourth way how we obtain base. When a salt like PbNO3, copper nitrate, sodium nitrate, when they are heated, we obtain their respective oxide like PbNO3 whole 2. Heated, we obtain PbO, NO2 is gas, oxygen is gas. So thus PbO we are obtaining in this way, which is a kind of base. How we prepare base in this way? How are their classifications? How are their tested? The test can be done in different way. Different kinds of indicators are there how we test the bases. We have the litmus paper. The red litmus turns blue. A red litmus turns blue if the moist litmus paper is brought near the base. So one way how to test them by the help of indicator. We have another kind of indicator which is called methyl orange that turns yellow. Similarly, we have phenolphthalein solution which turns pink when brought near the bases. Fourth one, that turmeric paper also is a kind of indicator that turns yellow when brought near the bases. So this is how we test them in different ways. So this is all about the bases we discussed. Now we are coming to the next topic, our salt. Salt means what? Salt means a kind of substance which is obtained by neutralization of acid and base. So this way, salt means not our only common salt that we use in our kitchen, we use in our health. That's kind of salt, that is one kind of salt that is used in our day-to-day life. So that is not the salt only. The different kinds of salts are there, dear children. What are the different kinds of salt? How are they classified? We are going to discuss about it. So that now we define firstly, a salt is a compound formed by partial or complete replacement of replaceable hydrogen ion present in that very acid. Let us come for one example that will give us how we are going to do so. We have sodium hydroxide. Sodium hydroxide is a kind of strong base. H2SO4 is also a strong acid. They combine together, neutralize the effect of one another, trying to neutralize the effect of one another. ये दोनों मिलकर एक दूसरे के प्रभाव को खत्म करने की कोशिश करते हैं. उसके दरमियान we are getting NaHSO4. That NaHSO4 contains still one replaceable hydrogen ion. एक हाइड्रोजन आयन उसमें और है. And a salt NaHSO4 sodium bisulfate forms. This is acid salt. Why we say acid salt? A kind of salt because it contains at least one replaceable hydrogen ion into it. So ये एक तरह का acid salt. At the same time, when we replace both the hydrogen ion of the acid by NaOH, we obtain Na2SO4. That Na2SO4 does not contain any kind of hydrogen ion into it. कोई हाइड्रोजन आयन इसमें प्रेजेंट नहीं है. ये नॉर्मल सॉल्ट हो जाएगा. नॉर्मल सॉल्ट लाइक NaCl, which does not contain also any hydrogen ion into it. ये नॉर्मल सॉल्ट हुआ इस तरह से. Now we are getting the basic salt. Basic salt means which has at least one hydroxyl ion present into it. So, by partial replacement of hydroxyl radical, if a salt is prepared, that will be called basic salt. Copper hydroxychloride, basic copper chloride is a kind of basic salt. We are having another kind of salt that is called double salt, formed by mixing of saturated solution of two simple salts and followed by their recrystallization again. Like we have potassium, K2SO4, here is potassium, K2SO4, Al2SO4, whole 3, 24H2O, potassium it is called. Fitkiri also. It is also called fitkiri in our common language. So this is obtained by two salts, K2SO4, Al2SO4, whole 3, 24S2, obtaining by recrystallizing them. So this is one kind of double salt. We have another double salt, ferrous ammonium sulfate, NH4 whole 2SO4, FeOH, FeSO4, 6H2. So this is another kind of salt which is called another name more salts. So like this way we have different kinds of salt and having their preparation, how we prepare them. Direct combination is one kind of method of preparing salt. Fe plus Cl2, FeCl3, Fe plus Cl2. When Fe is heated, chlorine gas is passed, they combine together to form FeCl3, a kind of salt FeCl3. Another way to prepare by the process of titration. First step is titration. Like here you see solution of NaOH. In the burette we have the H2SO4 as an acid. NaOH have been given some phenolphthalein solution. It has become pink in color. Now by drop, acid is allowed to fall into this 25 ml of NaOH, and we try to obtain the neutralization point, the end point of this very basic nature of NaOH. So drop by drop acid is dropped and it is second together so that the pink color is going to neutralize. The end point is obtained, that is the second step. Third step, when this end point is obtained, the process of filtration is there. After filtration, evaporation happens. Cooling them. When after evaporation, the cooling is done, and by cooling after that, the crystallization of that very cooled solution is done, and we obtain Na2SO4, 10H2. By this process here, NaOH plus H2SO4, Na2SO4 plus H2, and in this way we obtain by the process of titration the second way of preparation of salt. Another ways are there by the process of which soluble and insoluble salts are also prepared. That can be seen in the book. Now further on in this very process we are finding that there are different certain terms are there related to properties of acids. That is called the anhydrous salt. Anhydrous salt means the salt that does not contain any kind of water molecule like NaOH, NaCl, Na2SO4, like that way, which does not contain any kind of water or hydrogen ion into it. That another kind of property is that hydrated salt. We discussed that hydrated salt like K2SO4, Al2SO4, whole 324S2, that contains certain number of water of crystallization into them. So water of crystallization, another point that comes into play. So that what is water of crystallization? Water of crystallization means those water molecules which are loosely bounded with the salt. वैसे वाटर के मॉलिक्यूल जो सॉल्ट में लूजली बाउंडेड होते हैं, that when it is heated up, the water molecule goes into the atmosphere. So that is, we have Na2SO4, 10H2O, also a kind of salt, hydrated salt that contains water molecules, and that is 10H2O. 10 water molecules are there associated in one molecule of Na2SO4. Then we are coming over the deliquescent substance. The substances are there when left into air that absorbs moisture from the air. हवा से वाटर मॉलिक्यूल को, हवा से नमी को एब्जॉर्ब कर लेता है और एब्जॉर्ब करने के बाद उसमें घुल भी जाता है. जैसे MgCl2, CaCl2 ऐसे salts हैं. When they absorb water from the atmosphere, when they absorb moisture from the atmosphere, it dissolves into it and comes into liquid state. So that is one of the property of this salt. At the same time, hygroscopics are such substances that absorbs moisture from the atmosphere but does not change its state. Like H2SO4, when it absorbs water from the atmosphere, then it does not change its state, it remains in the liquid state. Calcium oxide, quicklime, absorbs water from the moisture from the atmosphere but does not change from solid to liquid state. Such substances are called hygroscopic. Now one more substance is that efflorescent substance, the substance that left in the atmosphere that loses its crystallization, like Na2SO4, Na2SO4, 7H2O or 10H2O, that when they are left in the atmosphere, they loses its what of crystallization. So such properties are there, such terms are there related to acid, base and salts. Thank you all and have a nice day.